Hi everyone, today in Integrated Math 1, we're going to go over Chapter 10, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple of our new definitions. Our first definition is point. A point is an exact location. It has no size, only a position. And notice here, it does say points usually have a name, often like a letter, A, or even W. As long as you label it, it really doesn't matter. So I have point A, B, and C here. Notice I can move them all around. Remember, part of our definition of a point is an exact location. Notice there's not like a particular size, we just have dots with them. It's only a position. So as you can see here, this point here is now has an x-coordinate of 2.0 and a y-coordinate of 8.0. But if it moves, it could change to 3.1 and 6.7. Remember, the point is an exact location, so if you move your point, the exact location is going to change. Our next definition that we're going to be talking about is lines, which are straight, it has no curves, has no thickness, and extends both directions without end, so infinitely. So let's look at our example here. So we have point A and point B, but notice it does not stop at point A and B. Notice our line keeps on going. Think about them having arrows at both ends, because honestly, we don't know if it even stops here, because it doesn't. So the next thing we have here that we want to go over is rays. So when we're talking about rays, notice the difference of what happened between the line and the ray. This other half that was going on infinitely is now gone. We have an endpoint and one part of the line that extends forever. So that's the difference between the line and ray. Think about the ray being half of the line in a sense. Okay, so now we're talking about segments. Segments. Notice here how we have point A and B and they're connected. But also notice how it does not go past A and B. That's the difference between a line and a segment. A line goes infinitely in both directions forever and ever. A segment, it has two endpoints, which in our case is A and B. So the next thing I want to go over is a plane. A plane is a flat surface with no thickness. So as you can see here in our little example, so notice it has no thickness and actually it goes on forever and ever. This is just more of a way so you can kind of get a grasp on this one. So there you go. Collinear. We're talking about lying on a common plane. 3 points are always collinear because you can have a plane that they are all on. But more than 3 points is usually not on a plane, unless we carefully choose them to be that way. So as you can see here, for our points, they are all lying on the same plane. Notice the name, collinear. We have with the plane. So now let's check, like we were talking about, if it was more than 4 points. It was more than 3 points. So in this case, it was 4. And notice, like they said, it has to be carefully laid out. If it's carefully laid out, it can happen. So this is another plane with 4 collinear points. Alright, our last definition is collinear. Notice co, which is with, line. So we're thinking, we know that it's going to have to do with something with the line. So we have all these points, as you see, A, B, C, and D. And what you should notice is that no matter what way I move this A or I move this B, or I move this C, you should notice that no matter what, they're still forming a straight line. Because when it's collinear is when we have 3 or more points that lie on a straight line. That's the definition of it. 2 points always make a line. And there we go.